Greetings, folks. Welcome. Regression analysis is a really important tool that economists use to look at the relationship between two variables. Here's a population regression model where we're looking at the effect of time spent studying on a student's grade. And this model is grade equals beta subscript 0 plus beta subscript 1 time spent studying plus epsilon, where epsilon is the error term, recognizing that there are lots of other factors other than how much time you spend studying on your grade. Below it, you see a sample regression model, and this is sort of that same version of the model, but this is one you can estimate based on data you can actually collect and analyze. So on the subject of collecting and analyzing data, here's a scatter plot that shows information on 40 students. You have the test grade, which is the dependent variable shown on the y-axis, and the number of hours studied, which is an explanatory variable shown on the x-axis. And since we can show both of these variables on a scatter plot, we know they're quantitative variables, and that's because you really can't show categorical variables on a scatter plot. And this raises the question, can we use categorical variables in a regression model? If you go back to our original version of the regression model, we're looking at the relationship between your test score and time spent studying, knowing that there are other factors. In other words, we had that error term, and another factor that might affect your performance on a test could be your college major, and college major is a classic example of a categorical variable. Here we have a data set with a small number of people in their college major. To keep things simple, I just stuck with majors that started with the letter E. So you have the economics major, engineering major, and education major. You see Susan is an econ major. Sue and Juan are engineering majors. Todd's an economics major. Quentin is an education major. Robbie is an economics major. And Pamela is an education major. We could also use numerical values to code the majors. So here we have the exact same information, but instead of writing out the name of the major, we actually show the numerical code. So economics students are coded with 1, education students are coded with 2, and engineering students are coded with 3. To incorporate categorical variables, so this could be something like a student's major, into a regression model, we use what are called dummy variables, also known as indicator variables. And dummy variables use values of 1 and 0 to indicate if an observation falls in a particular category. When we incorporate dummy variables in a regression model, the number of possible categories, and in our example there were 3 possible majors, determines the number of dummy variables. But when we actually go to include the dummy variables into the regression model, we need to have one what we call excluded category. So instead of using all 3 dummy variables, we only use 2 of the dummy variables, accounting for 2 of the categories. And then when we actually get our regression results, the results for the dummy variables are interpreted relative to the excluded category. And I'll show you what this means in a second. Let's go back to our data set showing college majors. And since we only have 3 college majors, that is, you could be an economics major, engineering major, or education major, we have 3 dummy variables. The first dummy variable is labeled as econ dum, and that indicates using values of 0 and 1 whether or not you're an economics major. So we have 3 people that are economics majors, Susan, Todd, and Robbie. The second dummy variable we're labeling as education dum. Here we have 2 students that are education majors, Quentin and Pamela. And then the third dummy variable is labeled as engineering dum, and it shows that you have 2 engineering majors, Sue and Juan. When we go to incorporate information on a student's major into the regression model, we have to decide which of the categories we're going to exclude. And in this first version of the model, we exclude the variable education dummy. So you see econ dummy and engineering dummy. So now the regression model is grade equals beta subscript 0 plus beta subscript 1 times the amount of time spent studying plus beta subscript 2 times economics dummy plus beta subscript 3 engineering dummy plus epsilon. So in this model, the parameter beta 2 tells us the effect on a student's grade from being an economics major compared to somebody who's an education major. Again, education major is the excluded category, also controlling for the time spent studying and whether or not you're an engineering major. In this model, the parameter beta subscript 3 tells us the effect on a student's grade from being an engineering major compared with somebody who's an education major, because still we're not including the education major dummy variable in the model, controlling for the time spent studying and whether or not you're an economics major. Because again, the economics dummy variable is in the model, so you're controlling for that as well. It might seem like a big deal which of the dummy variables to exclude from the model, but it's really not. If you're simply trying to control for the influence of a student's major on their test score, it really doesn't matter which major you exclude from the analysis. And that's because the effect of studying on your test score, and again, that's the parameter beta subscript 1, is exactly identical whether you exclude economics, education, or engineering majors. And that's because having information on those three majors and then excluding one of them from the regression model is a way to control for the influence of a student's major on their test grade. It doesn't matter whether you control for the influence of a student's major on their test grade by excluding the economics, education, or engineering majors, you get the same result for the effect of studying on the test grade. Now, where your choice of which dummy variable to exclude does matter is when you're interpreting the coefficients beta subscript 2 and beta subscript 3. In other words, the impacts of your major on your test scores differ depending on the category that's excluded. So let's say you excluded the dummy variable for economics majors from the regression model. That would mean that the impacts of the dummy variables for education and engineering majors would be interpreted relative to the economics majors, which is your excluded category. But you could have just as easily excluded one of the other two college major dummy variables. So let's say you'd excluded the dummy variable for engineering majors, then you'd interpret the results for the economics and education dummy variables relative to engineering majors.